All right. So, have you had a chance to take a look at this closely? So, there's a couple of things to point out here while you're inspecting this. Um, Probably the most notable thing is that this is supposed to represent gun deaths. And typically, when we see something that goes from bottom left, upper right, we think that this usually gives us an idea that a trend is increasing towards the positive. And what's really happening, and this is because in mathematics, this is the way that we're trained, is that if we have a chart and this is the amount of revenue that we're generating, if this was dollars on the left and this is time at the bottom, we would think that, hey, we're making more money over time. That's kind of what we are used to seeing. So when we see gun deaths and we see this first half, we think that they're increasing. And then we see this moment in time when Florida puts in their stand ground law, and then we see this sharp decrease. So since the title says gun deaths in Florida, we automatically think that gun deaths go down. But in reality, if we look at this number here, this is 0, and then this is 873. So what's happening here is that beforehand, instead of gun deaths going up, gun deaths are actually decreasing. And when the stand your ground law gets in place, the data tells us that gun deaths go ahead and begin to increase once again. Now, why did the authors do this? It could be just the fact that also we have a tendency to think that when things are going up like this is a good thing if of course if we're talking about money, but if we're talking about death, it would be better if it went down, right? So this would be a good thing. That's why I think that people might be thinking this. However, it's not representing that story that quite well. So let's take a look at what would be an appropriate way of doing this, creating this chart. How is this different? Well, all that's really happened is that this graphic flipped the y-axis here, and now we can see the real story of that when the Florida Stand Your Ground law occurred. Now death started to increase again. All right. Now, there was a graphic that was created at one point in time, and I pulled it up here. It is, if you did a quick search for the words Iraq's bloody toll, you'll find this article in The Economist, and it talks about what actually happened. But one of the visualizations that was in this article was this visualization right here. And this visualization, and I know you can't see the details, but this is a high number here at the bottom, and then 0 is up here at the upper left. And the reason why I wanted to show you this visualization from this page is because take a look at this right here. This visualization had won several awards, right? And the reason why it won awards is because this actually ended up becoming a major graphic that shows the dripping of blood, and then the greater the length of blood means the greater the amount of death when it came to the Iraq War, right? So this was very powerful, this was very effective, and in the right context, it was obviously recognized for its achievement. Okay. However, when this particular graphic was put together, they were trying to show a similar type thing by showing that the longer the amount of blood that's dripping, that means more death, and they were kind of trying to show that information, but it was misinterpreted. By the way, this is real data. You can go look it up, and it kind of gives you an idea about how data visualizations can be harmful. All right. Data visualizations, all right, need to be created from a summary table, usually the best way. Help us interpret, analyze, and learn from our data. Also, visualizations, and we saw it in the previous lecture, helps us find errors, and also helps reduce the size of our data set to highlight important relationships. All right. Most important, we're talking about decision making here, and data visualizations help us with decision making. All right. So I'm going to skim through these chart types, and you've seen a majority of these chart types before. Working with Microsoft Excel, most of these are available. Not all of them are available, but let's kind of talk through them briefly. All right, this is a bar chart. Typically, bars are go from left to right. I always tell students that if you had a mug of beer, you would set it on a bar. So that horizontal alignment is the bar. Typically, vertical alignment are column charts, but in this particular visualization, we're also calling it a bar chart. I always kind of think about like if we're building some kind of like large structure, like a palace in Greece, they have a lot of columns in the front. So these are column charts. Okay. The next is a box plot. We talked about box plots a little bit. Typically, the middle line is the median. This is the minimum. This is the maximum. And this quadrant here is the first 25% of the observations. Then this is the next 25%, or this is the third quadrant, or the next 25%. And this is the fourth quadrant. So box plots gives us information on the quadrants, right? And simply the only difference between the box plot here and the one here is that the max value would be at the top here, and the max value would be on the far right on this one. So it's just same thing, just turned on its side. So a choropleth is a shaded map, and usually the darker the color means a more dense type number. So this could be population, it could be voters, it could be temperatures, but whatever the amount of information, this could be the number of senior citizens that are retired. So you can see that Florida down here at the bottom is very dark. Here you have Michigan's also a darker blue. Nevada is also a darker blue. So it's a good chance that we might be looking at the darker the color, meaning the more of a certain measurement that we're taking. We'll see like Virginia is a lighter blue, so to have a less density of retirees there, if that's the measure we're looking. Now, Gantt chart typically is a matter of time being at the bottom. So this could be January all the way to December of this year. And each one of these bars represents a task. So this would be the length of time that that task has to take place. This is the next task, and it happens in parallel the same amount of time as the other task. After those are done, a new task takes place, new task, and a new task. That's a Gantt chart. All right, a heat map. So it's a lot like the choropleth, but it doesn't necessarily have the geographic locations. Usually something like this might be something like the hottest value is a very warm color that's very saturated. And then the coolest color would be more of, or the lowest value might be a cool color that's not so saturated. And this kind of gives us where certain values are hotter or colder. This could be something also, again, greater density, could be heat. Say this was a window pane, and on that window pane, we can see that the top right-hand corner got warm, and then the bottom left-hand corner is less warm, and then we have some other patches of heat here, and it could be some type of measurement that we're trying to look at. All right. All right, so here's a histogram, and we spoke about histograms before. And this is usually in some kind of bell shape or normal distribution. We've talked about that in the past. Okay. And I'm looking at the clock, so I'm going to pause right here on histogram, and we'll pick up the rest of the data visualizations in the next video.